So, quiz 8. First question starts off with finding the domain of the rational function x squared plus 4, all divided by x squared minus 2x minus 8. And we want to express our answer in interval notation. So, anytime we're finding domains of functions, we have two requirements. The first requirement is the denominator cannot be equal to
0.
Exactly. And the second requirement is we don't want any negatives under an even root. Lucky for us, in this case, we have no roots or radicals, so we don't have to worry about that second one. But we do have a fraction, and so we have to set that denominator equal to 0 to find our restrictions. X squared minus 2x minus 8, can that be factored? Yeah, what can it be factored into?
-4 and 2.
Yep. Which tells us our two values that x can't be are what? Negative?
2 and 4.
Exactly. If we were to look at this from a number line standpoint, we would have closed circles or open circles at -2. Open, because we're not including them, but we're including any other value in that real number system. In interval notation, what does this look like? -infinity, comma, union,
-2, 4.
all soft brackets, union,
4 and infinity.
yep, and we're done. Questions at all? Yes.
I'll be honest, I forgot to put the -2 and 4. So do I get partial credit for that or not?
You'll get partial credit. Yeah. Mhm. Okay, let's move on to question 2, where we're asked to find the x and y intercepts. Definition of x-intercept is when y is equal to?
0.
Good. Definition of y-intercept is when?
X equals 0.
Yep. Let's do y-intercept first. Usually that's the easier one. So our r of 0 is just 0 cubed plus 8 divided by 0 squared plus 4. The zeros essentially disappear, so we're just looking at 8 over 4, which tells us that our y-intercept is 2, but they ask us to put it into coordinate form. So that is just,
0.
yeah. X-intercept. Do we have to take into account our denominator here? Nope. Because as long as the numerator is 0, 0 divided by any real number aside from 0, but there are no values of x that will give us 0 as the denominator. So 0 divided by anything is 0. Subtract 8 from both sides. You'll notice, oh, we're going to have to take a cube root of a negative number, which is that possible?
Yeah.
It is. What is the cube root of -8?
-2.
Yeah. And so in coordinate form, our x-intercept is?
-2, 0.
Yeah. Any questions on the first page? Right, let's go ahead and move on to question 3. I should probably move that slide to after the quiz. All right, question 3. We're asked to determine our horizontal and our vertical asymptotes from a visual standpoint. So we're given a graph here. And maybe what I'll do is I'll really pronunciate our asymptotes. So our vertical asymptotes, which I have highlighted in red here, are at what numerical values? X is equal to?
Negative.
Mm-hmm. And then what about our horizontal asymptote? Y is equal to? Yeah. And then last but not least, we have question 4, where we're asked to find the vertical asymptotes of this function. And this is where I kind of want to bring back our recap of what we went over during our last class. When you are identifying domain, you want to look at all of your restrictions. It doesn't matter. I shouldn't say it doesn't matter. You don't want to put your function into lowest terms. You want to look at your denominator and figure out all of your possible restrictions and then exclude those from your domain. And maybe I'll shrink this a bit because you can't really see the bottom. But when you're analyzing your vertical asymptotes, it's slightly different. You actually want to put it into lowest terms first, and then once it's in lowest terms, then you want to go ahead and analyze what your restrictions are. So what values of x make that denominator equal to 0? So we're really honing in on that second one when we're solving question 4 on our quiz. We want to simplify the fraction first to its lowest terms, and then we figure out what our vertical asymptotes are. So we're looking at our r of x. That numerator can be factored into exactly, and then that denominator can be factored into x minus 3. Yeah, exactly. Which means what can be canceled out from the numerator and the denominator? Yeah, so in simplest or lowest terms, we have our function as x plus 2 over x minus 3. Now we are going to go ahead and look at that denominator and figure out all of our possible restrictions. X minus 3 cannot be equal to 0, which means x cannot be equal to 3. And that tells us that we have a vertical asymptote at x is equal to 3. And this is our only vertical asymptote. Oops. Any questions? Yeah.
2 points off is if we did x equals 2 and x equals 2.
We'll probably get like 1 point off. Yeah. All right. So that concludes our quiz 8.